All right, Algebra 1, Lesson 6.4. We've looked at the 3 ways we can solve systems of equations. We looked at graphing, substitution, elimination. Now we're going to look at special systems, things that might come up when you're solving them in one of the ways that you choose. So first, let's start with our warm-up. So solve each equation. So if I were to look at this first equation, I see that the 2x's cancel, and I just get 3 equals 4. Okay? So remember, in a normal equation, that would be no solution. For this next one, I have to distribute first. So I get 2x plus 2 equals 2. So when I have the same thing, that's infinitely many solutions. So this was no solution. So these are for normal equations, what they would be. For this next one, we need to solve for y. So we have 2y minus 6x equals 10. So let's move this 6x over. I'm going to write over on this side. So we get 2y equals 6x plus 10, and then I divide everything by 2. So y is equal to 3x plus 5. Okay. On these next two, we're going to review solving. So we can solve, it says, any method. So you can choose graphing, substitution, or elimination. Like I said, graphing is the one that you have to be really careful on. So I would probably choose substitution or elimination, but if you want to go with graphing, you can. So for this one, I'm actually going to substitute, because this is already solved for y. I'm going to substitute it into that y. So I get 2x plus 3x plus 2 equals 7. So then I get 5x plus 2 equals 7. Then if I move things over, I get 5x equals 5. So x is equal to 1. If I plug that back in up here into this x, I'll get y is equal to 5. So there's my two solutions. For this next one, I'm actually going to eliminate, because I see that these are already opposites. So if I combine equations, x and x makes 2x. Negative y and positive 2y just goes away. And then 8 and 4 makes 12. And then I can divide by 2, and my x value is 6. If I plug that into one of the equations, if I plug it in here, I'll get 6 minus y equals 8. So by moving things around, I'm going to get y is negative 2. Okay? All right, so today, though, for this lesson, we're going to look at solving systems with two variables, and then how to tell if we get a different answer than what we normally expect, how to classify those types of solutions. So we're going to hear the words inconsistent and consistent system, and we're also going to hear the words dependent and independent system. All right. So here's the classifications and how they work. If you solve a system, like we did in the warm-up, those last two, and we get one solution, meaning an x and a y, that's one solution, we call that a consistent system, okay? If we get infinite solutions, okay, if something equals something and it's true, that is also a consistent system. If we get something that's not true, like we can't get a solution, then it's inconsistent. Then within our two types, we have, if we have a solution, we have independent and dependent, and I'll talk about those in a second, okay? So in the first lesson, you saw that if the two lines intersect at one point, that's just one solution. If there's at least one solution, we call that consistent. So if they intersect at least one point, they have to have at least one solution. They're consistent. If two lines do not intersect because they're parallel, then we have no solution, and we call that an inconsistent system. Okay? This one is either I have one point, so they cross at a point, or they're the same lines that overlap. That's consistent. Inconsistent is when there's no solution because they're parallel and don't overlap at all. Just remember, be careful. If you get something that is true, like 0 equals 0 when you solve it at the end, or 5 equals 5, it doesn't mean it has no solutions. It means that there are infinitely many on the line. They're the same line, they overlap each other. If it's something that's not true, like 3 equals 4, that is no solution because they're parallel lines. So really pay attention to this caution right here. All right, so let's see what we get on this one. We're going to solve it. You can solve it any way you want. I am actually going to substitute because I already have y equal. So I'm going to put that into y. So I get negative x plus x minus 4, because I substitute that in for y, equals 3. That goes away because negative x and positive x. So I just have negative 4 equals 3. This is not a true statement. So if it's not true, what do we call that again? That is no solution. Okay, so that is not true. So therefore it is no solution. So that just showed that since I got something that is not true, they are parallel. Okay, so we showed that. Okay, on this next one, they want us to solve it, and then by using the substitution method, because the first equation is already solved for y. So we're going to substitute this in. Actually, we're not going to substitute in because that's the example I just did on the last slide. I just must have rewritten it twice. So because we got no solution on this one, they're going to show you graphically now on a graph why it's no solution. If we were to graph these two lines, like if I were to rewrite this one and move the x over, so if I were to graph these two lines, they end up being parallel lines. That means they never intersect. So that's why there's no solution. And if you remember, the no solution one was an inconsistent system. Okay, so if two linear equations on the same graph, if they were the same line, that would be consistent. But these actually weren't the same line. They were different. They didn't intersect. So that this one up here was inconsistent because they never intersected. If they had, that would have been infinitely many solutions if they had been on top of each other. Okay. All right, so let's see if this one has infinitely many solutions. So we're going to solve it. You can solve it any way you want. I would probably substitute because I see that this is already solved for y. So if I plugged that into y, I get 3x. Now here's where you have to be careful. This is a minus y, so it has to be minus this whole thing. So now that makes this a minus 3x and a minus 2 and a plus 2. Well, what happens to these? These all cancel, and we get 0 equals 0. So that is true. It's a true statement. So therefore, if it's true, they're right on top of each other, and that is a consistent system. They're the same lines, okay? Now, let's look at the two types of consistent systems we can have. So inconsistent means there's no solution. Consistent means I either have a lot of solutions or one. Now, if you get consistent systems, they can either be independent or dependent. Independent means that it's just one solution, meaning they just intersect at one point. Dependent means it's the same line, like one line and then another line. It's the same line on top of it. Okay. So the way I remember it is if it's independent, they're independent lines. They're independent of each other and just intersect at one point. If it's dependent, they're the same line on top of each other. So again, these are both consistent. This is a really helpful chart. I would recommend kind of just memorizing it and making sure you know what's going on. This lesson has a lot of vocabulary. So go through, we're going to go through some examples right now and see if we can remember what everything is. So they want us to solve and then classify. You can solve it however you want. I'm actually going to multiply this one by 3 because that will make this negative x. That will make this positive 3y, and that will make that 3. Now, once I have that, I'm going to flip things around and kind of make it so that it looks like the other one, I'm going to move the x over here to this side. Now if I line up that equation, 3y equals x plus 3, and this equation, 3y equals x plus 3, when I subtract the one from the other one, so if I were to subtract this one, everything would cancel and I would just get 0 equals 0. So first of all, let's decide what kind of system. Is it consistent or inconsistent? Well, it has infinitely many solutions. So it has infinite solutions. So it is a consistent system. Now, is it independent or dependent? If it's infinite, they're lines on top of each other. They're the same line. So we say that they're dependent because it's the same line, kind of like depending on each other. All right, let's try this one. I'm going to subtract. I'm still going to use elimination, or actually, no, I'm not. Not on this one. I lied. I'm going to rearrange it first. I'm going to move this to this side and the 4 to that side. So let me show you. 4y equals negative x. I'm going to move the 4 over, so I get y equals negative x minus 4, and then move the x back. So I get y plus x, or however you want to write it, y plus x equals negative 4. Now, I'm going to line them up. So I'm going to write my first equation. I'm going to write my second equation, and I can flip the x and the y on that side. It's okay. When I combine these equations, if I subtracted this one, if I subtract the x from the y, the x's and y's, this goes away, so I get 0 on this side. This makes a positive 4, so I get a 9 when I add it with the combine it with the 5. So 0 equals 9. That is not true. So it's no solution, and therefore it is an inconsistent system. Okay, next one. I'm going to distribute first, so I get y equals 4x plus 4. And for this one, I'll just substitute that in. So I get 4x plus 4 minus 3 equals x. Then I'm going to get 1 when I do 4 minus 3. I'm going to subtract from this side my 4x. So I get 1 equals negative 3x. Divide by negative 3. So my x is negative 1/3. We should go on to solve for the y value because we did get one solution. So if it's one solution, it's consistent, but it's also an independent, consistent system. So I'm not going to do it right now, but you should plug that in and go solve for your y value also. We're just classifying right now. Okay, let's try a couple more. All right. Word problems. I know you guys love these. Please watch this because you always have questions on it. Jared and David both started a savings account in January. If the pattern of savings in the table continues, when will the amount in his account when will Jared's equal David's? So Jared is depositing this much money each month. David's depositing this much. Okay. So this is what they're depositing. This is how much they have in it. So we want to use the table to write a system of linear equations. The y is going to represent the savings, the total savings, and x is going to represent the number of months. Okay? So let's look at what type of equations we would come up with. So just to kind of look, Jared starts with $25, okay? When he has the next month, he has 30. That means he put $5 in. The next month he has 35, so he put 5 in. The next month he has 40, so he's adding 5 each month. He started at 25 though, okay? David started with $40, and he's adding $5 here, $5 here, $5 here, and $5 here. So David's adding $5 each month, Jared's adding $5 each month. Jared starts with 25, David starts with 40. So let's come up with our equations. Well, our equation is going to be the total saved is equal to the starting amount plus the amount saved each month. where we know the month is our X and our Y is the total saved. So Y is equal to the starting amount. Jared had 25 to start, plus his amount saved per month. He's doing $5 every month. So we'll use an X. David's doing $40 to start plus $5 per month. So we want to know when will this one equal this one. So we're going to set them equal since they both equal X. When I subtract 5X, that's going to go away, and I just get 25 equals 40. So that is not a true statement. So that means this is a word problem. They wanted to know when will their accounts have the same amount of money. Well, if we can't get a solution, that means it's no solution. They will never have the same amount of money if they keep going at this rate. So they will not have equal amounts ever, assuming they go at this rate. Okay? So again, this lesson has a lot of vocabulary. You guys just have to read it, practice it, and memorize it. And that's it.